Welcome and thanks for watching. Today I want to talk about some of the cool things you can do with this, the VP14 LCD controller. Now if you're familiar with LCD controllers, you probably know that they come in all shapes and sizes and can drive a variety of displays. Most are designed to handle a range of input types and resolutions, but we've taken our product design a step further. We have added features into our LCD controllers that empower you, the display manufacturer, to customize how your product handles a multitude of video inputs. One such feature is something we call mode handling, which gives you a wide range of options to configure how incoming video is presented on the display. So as your input video source changes, the display content looks just the way you want. In this video, I'm going to discuss mode handling and how it can be used to customize your display. So if you're looking for a programmable LCD controller with advanced features, or if you need to be able to process and control a range of video inputs, please stay tuned. Hey, it's JW Powers with Westar Display Technologies. Today I'm going to discuss mode handling using our VP14 LCD controller. This overview is also relevant to other Westar LCD controllers such as the VP13, VP15, 16, and VP17. In this video, I will provide a quick overview of the VP14 and its capabilities. Then I'm going to set up a display using two video sources to illustrate how mode handling works. I will show various configurations with either one or two inputs displayed at a time, and how the VP14 can process various input modes. I will cover what a mode is and how it works, what you can customize and control with modes, and typical applications where mode handling is useful. We won't discuss the details of cabling or other cool features, such as customizable on-screen messaging, but we have plenty of resources available if you'd like to learn more. So let's get to it. Westar released the VP14 in late 2018, and this controller in many ways builds on the capabilities of our VP7 series boards. In its base configuration, the VP14 is a single board that measures 5 inches by 4 inches. It uses Hiroshi connectors for I/O, is RoHS compliant, and rated for temperatures ranging from 0 to 7 degrees Celsius. However, many customers extend well beyond this temperature range in their specific application. The VP14 can drive up to wide UXGA displays. It supports single or dual LVDS panels up to 165 megapixels per second, single pixel parallel digital for displays up to 1080p, and we offer adapters for additional output types such as DisplayPort and MIPI. For video input, the VP14 supports resolutions up to wide UXGA and has 2 ports, one standard and one accessible using optional input mezzanine boards. On port 1, the VP14 supports DVI, VGA, component, composite, RS343 and RS170, and S-Video. The VP14 will process a single video feed per port on any channel or subchannel that you specify, while supporting electrical connections to multiple channel types at a time. Port 1 also includes a programmable EDID for DVI and VGA inputs. Port 2 supports optional mezzanine boards if you need to process and display 2 video feeds simultaneously, or if you need access to additional input types. We offer input mezzanines that support DisplayPort, 3G SDI, LVDS, or you can have an additional multi-standard decoder with the same connections as available on port 1. These are our most popular input mezzanines, but we have others for specialty applications, and we continue to design more. So just let us know if you don't see what you're looking for. The VP14 also includes discrete I/O interfaces, on-screen messaging with built-in font generators, and remote LEDs for board and video status. Video contrast and backlight can be controlled via discrete or analog input, rotary encoder, or remote command. The VP14 packs plenty of features for video processing such as windowing, resizing, and area of interest control, just to name a few. Some of these, which we will demonstrate here in a minute. The VP14 comes with configuration software used for setup, and can be dynamically controlled via RS232, USB, or optional Ethernet. That's a quick overview of the VP14. Now it's time to demonstrate mode handling. Let's start here with our setup. We have a 15-inch LCD module connected to the VP14 via LVDS. The resolution of this panel is 1920 by 1080, operating at a refresh rate of 60 Hz. For our primary video source, we have a T-Drive 3 test pattern generator hooked up to input port 1, connected over DVI. We will use this to generate video at different resolutions and timing. For example, 1080p, 720p, and a few other formats. For our second video source, we have a 1080p SDI video camera, which is over here, connected to port 2 using an SDI mezzanine board. Our VP14 is typically powered with a 12-volt DC supply, as we have here, but it can accept anywhere between 6 and 28 volts DC. For configuration and dynamic control, we are using RS232. Lastly, we have a video capture card connected to an output port. This port has identical content as the LVDS port to the panel and is used to record the output video to the panel. Your application, including display, video source, and timing, will most likely be different than what we have here, but mode handling is going to work just the same. Okay, now let's see how the VP14 works. I've already configured the VP14 output for this particular display, so we can make sure the output video looks good by enabling a test pattern. So here we have a test pattern displayed. There's no input video to the board at this time, just the test pattern output from the VP14. Since we were successfully driving the display, we can now turn on our video source. Using the T-Drive3 test pattern generator connected to port 1, let's start with the display's native resolution at 1920 by 1080. So here we have 1920 by 1080 output from the T-Drive3 going into the VP14 driving the display. Let's look at a few others. I'm going to change the resolution now to 1440 by 900. Now let's look at 720p. Now here's 1280 by 1024. Let's try 1600 by 1200. And let's do one more. Let's do 640 by 480. Again, this is output from the T-Drive going into the VP14. We can do more, but you get the idea. The VP14 has a mode defined for each one of these input resolutions. When the test pattern generator switches timing, the VP14 detects the input timing, matches it to a pre-configured mode, and then displays the output accordingly. This is fairly standard stuff. Many controllers can handle a variety of input resolutions. With the VP14, you get to configure the list of input resolutions, or modes, to detect and process. Again, what I've shown so far is just a few modes, but I could create more. When it comes to defining modes, the key parameters are the input port, which is either port 1 or port 2, the electrical connection type, such as DVI, VGA, DisplayPort, etc., and the video resolution and frame rate. In the configuration software, you can select from a list of standard video timing or generate CVT-compliant timings. For custom video formats, you can specify the exact timing parameters you want, including horizontal and vertical resolution, front porch and back porch, blanking, frame rate, and the pixel clock frequency. So again, you are now locked into a standard list of input video resolutions when creating modes, but they are there if you need them. Now, once you have defined a list of modes for a particular port, you can prioritize them and load them into the VP14. There are a couple of things to know about how the VP14 determines the input mode. First, for a given port, you can either specify the channel and subchannel to scan, or you can auto-scan. So for example, you might command the controller to look at DVI or VGA subchannel 1 or composite subchannel 2. The VP14 will then look for a match using the list of predefined modes. So if you select VGA for port 1, that port's mode handler will look for a match in the VGA modes. If you select DVI, the mode handler will look for a match out of the DVI modes in the list. If the VP14 is set to auto-scan, it will look for a match on subchannel 1 of each input type of that port, such as VGA 1, composite 1, DVI, etc. Second, you can specify whether or not the port's mode handler selects a mode that is an exact match to the input timing or a close match. Right now we have close match enabled, so if I change the input video source to something I didn't define, such as 1366 by 768, the VP14 will find a mode that is closest to 1366 by 768. In this case, it happens to be 1024 by 768. If I enable exact match, the timing must match a pre-configured mode or the input is not processed and any windows assigned to that input are set to a predefined color or removed altogether. So that's a quick overview of configuring the VP14 input modes. Now let's talk about what happens when a mode is detected. More specifically, how do we process the input video and what does it look like on our display? When I was scrolling through different resolutions earlier, everything was scaled to full screen on the output. However, depending on the aspect ratio of your input and your display, you may want to scale differently to maintain your aspect ratio and avoid image distortions. Most controllers will give you a few pre-configured settings, such as scale to full screen and some options to overscan or underscan. The VP14 can do this as well. So for example, I could choose to have wide UXGA fit to full screen, underscan with black bars, or crop to fit our 1080p display. You can set the port's mode handler to automatically default to any of these views when the input source changes. Or, using a mode selection identifier, you can have more than one view setting for a given input timing that can be toggled via discrete or commanded remotely. But you can take it a step further. For each mode, you can specify the exact area of interest on the input source, the window size and location on the output, and then customize further. You can add borders, flip the image, rotate the image, adjust gains, and more. If you wanted to do something like zoom in on a particular area and then rotate the image, that is easy to do. Or maybe you want to customize the way your borders look and adjust the location of the window. Again, very easy to do. Up to this point, everything we have shown was done using one input port linked to one window on the output. But the VP14 can have up to 4 windows. Each window can be linked to either port 1 or port 2. So you could link window 1 to port 1 and window 2 to port 2 if you wanted a split screen or side-by-side view, or you can link both windows 1 and 2 to port 1 if you wanted to do things like zooming or selectable area of interest. So let's see how this works. Let's set up a mode for our SDI video camera on port 2. In the mode configuration tool, I will create a new mode on port 2. We have a 3G SDI mezzanine attached, so we will select that. Next, we expect the camera to run at 1080p 60 Hz, so I will select that from the list. Now, once this camera is turned on, the port 2 mode handler should match the single mode. If the camera had an additional timing mode, such as 720p, I would simply create a mode for that as well, similar to what we have on port 1. But the camera only outputs 1080p, so I need just one mode. Now let's configure our windows. I will link window 2 to port 2. Let's start by showing window 2 only, so that whenever the camera is on, that is the only visible window, regardless of the video on port 1. If you wanted to flip the image or scale it, we can do that too. But perhaps we want the camera to be a picture-in-picture with the port 1 input shown in the background. For that, we specify the size of the pip and the area of interest. If you want to change the priority of the windows in terms of which ones get displayed in areas of overlap, you can do that using alpha values. You can do other things such as side-by-side or landscape view with 2 feeds, or maybe you just have one input and want to zoom in on a particular area. You can do that too by assigning the same port to multiple windows. As you can see, the VP14 is highly configurable for multi-window or multi-input applications. In most cases, you will pre-configure the VP14 modes per port and pre-assign windows to ports. But you can also make changes on the fly via commands. You can move windows around, change the area of interest, enable or disable modes, and much more. There's a lot that can be controlled dynamically via command if you need that level of flexibility in your design. As you can see, the amount of customization you get with our line of LCD controllers is huge. You may not need a custom designed controller when Westar has highly configurable off-the-shelf solutions. Our LCD controllers empower you to have maximum control when processing video inputs for your display. This flexibility allows you to provide new functions for your customer without changing your LCD controller. If you're looking for more information about our line of LCD controllers, visit us on the web at www.westardisplaytechnologies.com or contact us directly. Thanks again for watching.